How's it going, everybody? In this video, we're going to take a look at OSPF summarization and exactly how that all breaks down. But before I get into that, I wanted to let everybody know a couple things real quick. One, I had a major issue with the topology, and I actually had to, I was pretty much almost all the way through OSPF, and then I'm sure in the previous video you remember seeing all the LSA issues that I was seeing with, the bad LSA checksums and things like that. And then as I was trying to fix that by rebooting routers and stuff like that and fixing some configuration issues, I actually lost the virtual machine. I didn't create a snapshot of it, and it bugged out on me, and then truth be told, I rebooted the server that the storage was going to, and the storage for this particular virtual machine is actually stored on a remote storage device, and when I rebooted that, it actually blew away the virtual machine, the VMDK and all that stuff. So basically, which is the virtual machine hard drive, essentially. So what I had to do is I had to rebuild the virtual machine, I had to rebuild the topology, so a lot of things are not there that were before. So the authentication, I didn't, since I've already gone over it, I didn't see a reason to build the topology back up from where we were before. So it's kind of starting over a little bit fresh. The virtual links are in place and some other stuff, but for the most part, all the major things that were there are no longer there. So authentication and some other details. But we're going to focus on in this video is going to be summarization, and the reason why we're going to focus on that is because this is how you're going to clean up the OSPF database. This is how you're going to clean up the OSPF routing table. So if you understand how summarization works, which is pretty straightforward for the most part, but if you don't understand how it works, this is it's going to be unique. Now the other thing I want to show you is that we have a new topology as well. And the topology, it's the same format as where routers replaced, just the router numbers have changed. So before I had a pretty wide girth of, there's a block where there was no numbers involved, and so like 14 to like 18 and things like that. So here I've gone 1 through 14, and or I'm sorry, 1 through 16, and router 15 and 16 are frame relay switches. So they just have frame relay running on them. They're acting as a frame relay router, and that's pretty much all there is to it. So pretty much the exact same design as we had before. Nothing really has changed beyond that. The same addressing escapes and stuff like that, and some of the subnet masks have changed a little bit just for the simple fact that I didn't remember what exactly I had placed there, but that's okay. So what I'm going to do is we're going to get into the actual details of how this stuff works, and go through there and pick up from here and continue working on through our studies. And then as we get a little farther along into other technologies, we'll start bringing some other stuff in. And I think it's going to start getting interesting here once we get past BGP and DMBPN, because then a lot of the core topics will be covered, and we'll start getting into the peripherals like NAT and some security features and stuff like that. So back to our slides. So summarization. You're going to be summarizing the topology graph. Now this summarizing the topology graph is typically achieved through the OSPF area. So you hide the details of how the graph looks in other areas. What you do is once you have multiple areas, the ABR is the common point of insertion and extraction, which means it's going to be where you're sending traffic and where you're receiving traffic from. So what you're going to be doing is you're going to be solving the shortest path tree, or the SPT, to the ABR that's advertising that route. You're going to summarize. You're going to solve the SPT to the Type 3 LSA, and then once you have that solved, then you're going to be able to go from the ABR. The ABR is going to have the Type 1 LSA available to it, and that's how you're going to get to where you need to go. Now, when it comes to summarizing the network layer reachability information, you can summarize that through the stub area and the per prefix summaries. So summarizing Type 5 into a default route. We saw this inside of the stub and not so stubby area configuration, where we went in and removed all of the external routes and replaced them with the default route. Then we went in and removed all the Type 3 and 4. Well, technically speaking, 4 and 5 were both removed. And then if you see the Type 4 is simply being originated from the autonomous system boundary router that is going to be the owner in some cases, not always, of the external route, or at least have a route to the external route. because you might have an ASPR and he's receiving the Type 5 LSA and advertising it as a Type 4 in the next area, things like that. So now when you replace a longer match with a shorter match, that is what they refer to as network layer reachability information summarization, because you're taking a longer match and shortening it down to a shorter match. You can use this as traffic engineering if you'd like. So basically what that means is you can create a stub on one router and not on another, or you could manipulate how traffic is originated. So you could say, I don't want to have a stub, or I do want to have a stub, or I want to have a summary or a summary address, or if I want to have the area range, and longer match will win. So if you have two routers that are at the edge boxes of an area, you're going to be able to put the shorter match on one router, and the traffic will go the other direction because longer match will always win. So now when it comes to summarization in general, the drawback to summarization in OSPF is that it can only be performed on an ASBR or an ABR. That is it. So and you can only summarize there's a little caveat to this. You can only summarize where the route is originated from. So if you have a router in an area and let's say he's a backbone router for a non-backbone area like area 1. So he's an internal router. Well, what you end up doing there is he advertises a route up to the ABR. The ABR learns the route. Well, what ends up happening here is if you want to do any summarization on there, you can summarize a Type 1 to a Type 3 and send just a bulk of routes or one shorter match for all your longer matches that you have access to. You cannot do that upstream though. So you cannot, unlike BGP, you can go in and you can summarize as long as the route's in the routing table. With OSPF, if you want to summarize, you have to summarize and do your filtering where the route is advertised. Now you don't have to do that. I just said you do have to do that. So why am I giving conflicting information? Typically, you're going to do it at the point of exit for the area. Now you don't have to do that. You could try going somewhere else, and depending on the code, I've had mixed results with how that would work. Some code revisions they support it, some don't. So normally, and this is the best practice and what you're going to see in the exam, is you're going to be doing it at the point of exit of the area. So the ABR that owns the route. And that's the only time I've ever done it. So now with EIGRP and BGP, you can do it anywhere you want. OSPF, you have a strict leaf spine leaf, so you have to do it at an ABR or an ASBR, and that is all you can do. Now, the difference between an internal and an external summary is real simple. An internal summary is going to be going from one OSPF area to another OSPF area. And you're going to be doing your summarization on an ABR. So a router that has a link in each area. And you're going to be summarizing Type 1 LSAs into Type 3 LSAs. So what that means is you're going to take a group of individual routes and summarizing them into a single Type 3 LSA. And you're going to use the area range command to accomplish that. Now if you want to go from OSPF domain to a non-OSPF domain, you're going to use an ASBR for that. So the idea with the ASBR is to take routes that are coming into your network, and you're going to use the summary address command, and you're going to be taking routes that you learned in and summarizing them out to the rest of the network. So you could say, I want to advertise just the default route for any external routes. So you can type in default originate or default information originate, and then you can advertise. That's assuming you have a default route in the routing table. If you do not have a default route in your routing table, but you still want to advertise one, you'd have to tack on the always command to the end of that, which is the default information originate always, which means that even if I don't actually have a route in my routing table that's a default route, I want to advertise one anyway, because you might actually be the exit point for the network. It might be an ASBR that's doing that. The moment you redistribute on any OSPF router, they automatically become an ASBR because they bring in the Type 5 LSA. When you're dealing with Type 5 LSAs, you're given the ability for OSPF to leave the network. If you do not have a Type 5 or Type 7 LSA, that means you cannot leave your OSPF network. You have to stay internal to it unless you have some other configuration set up that I'm not familiar with, which, as far as I'm aware, that's the only way you can do it. So now, the nice thing about it, when it comes to external summarizations, you can summarize Type 5 LSAs into Type 5 LSAs, and you can do Type 7 and Type 7. So, Type 7 is not so stubby area specific. Type 5 LSA is external LSA specific. You cannot summarize an external into an internal. It doesn't work that way because it's a different route type. So, and you cannot summarize that. So that's why I say when you're summarizing, you cannot summarize from a type 3 to a type 5. It doesn't work that way. Now you can summarize a type 5 down into a shorter match, into a default route if you'd like, or use a summary address to take it to shorten the network length from a /24 down to a /20 if that's your due diligence. You can do that as well. But now the other thing to keep in mind here is when summarizing, OSPF automatically produces a what they call discard route. A discard route means that if you have a null zero route is advertised, so you're going to have the bare minimum subnet you're going to be using as your summary. So it could be a 10.1.1.0/22, and it can be to null zero, which means that if the longest match is the default or is the summary route, you're going to drop it because you can't guarantee that route actually exists or the destination is actually there. So because the drawback to summarization is you can very easily summarize too wide and have more summary routes than what's actually being advertised, and then you can black hole your traffic. You don't want to do that. You would want to make sure that you have a longer match wherever possible. And typically speaking, if the shortest match is the summary, you're going to drop it. But as long as there's a default route, you'll be fine. It'll forward it based off of the default route. So as we go through here, you'll see that it's not too terribly complicated. But if you don't get what the program is trying to tell you, then you can get into some problems. So we've discussed where you can summarize. Let's go a little bit more in detail about how that actually works. And so internal summaries are only at the ASBRs and only at the ABR who knows the LSA1. Now, why is that? Why is that important? Well, because of the fact that he is the exit point for that area. You don't want to be summarizing upstream because at that point it's already a Type 3 LSA, and you can't summarize an LSA into another LSA. So you can't summarize Type 3 into Type 3. It's already that LSA. So if you take a group of Type 1 LSAs and summarize them into an area on an ABR, you can't summarize them again. So you can't advertise the Type 3 to be another Type 3. It's already been summarized. It is what it is. So it'll be an OIA route when you get it. Now external summaries only at the ASPR who is the originator. So you're going to be performing either a Type 5 or Type 7 redistribution. Type 5, remember, is just going to be a normal redistribution from outside OSPF into OSPF. Type 7 is going to be outside OSPF into a not-so-stubby area. And then when it goes from the not-so-stubby area into a regular OSPF non-backbone or backbone area, it'll be summarized to a Type 5 LSA. Or I should say redistributed and translated over to a Type 5 LSA. And you have the ability to turn that translation capability off. This is what they refer to as the P bit. You can turn that off, and that would not allow the translation from Type 7 to Type 5. If you want that turned on, you can simply type, you can turn it on if you'd like. But the idea behind that is to prevent flooding LSAs where they don't need to go. So the drawback to that is you could be potentially lose reachability to the rest of your network. So what we're going to do is we're going to take a look at doing this on our topology. So I'm going to bring up our topology again. And this is our topology. And we're going to bring up our routers. And as you can see, I've got a basic configuration going here, right? We go down to router. Let's go up here. I'm going to go. We're going to be working between the frame relay network down here. So we're going to be working on router 11. So let's go to router 11 once. And I've got a debug running here, so I'm going to do a UAll. So I'm going to do a show IP route. As you can see, I have quite a few routes. Right? So what I want to do now is I want to take a look at. I want to summarize. I'm advertising. Let's see what router 3 sees. Router 3 should see the two routes from 11 and 12. What I want to do is I want to summarize all of the any routes coming from router 11 and 12 from 5 outbound towards router 3, and router 4 should see the same thing. Router 4 sees them as internal routes because they're attached to the same or or no, I'm sorry, the inter area, because router 5 is an ABR. So what we're going to do is we're going to set it up on router 5. We're going to say the origination area, so we're going to type in router OSPF 5. We're going to type in area 100, so this is the source area, and we're going to type in the area, the range for this guy, and what's going to be the mask. We're going to type in 10.255.0.0. So anything that's got 10.255 in it, we want to summarize. And then we're going to say what is the mask for it. Now normally these are going to be /32 routes, but I want to summarize it down to a /22. So /22 is going to be 255.255.252. I'm sorry, 254 would be a /23, and a 254 would be a /23, and a 252 would be a /22. So I'm going to do a 252.0. Okay, so now I should be able to go to router 3 and do a show IP route, and I've had issues with this in the past where it doesn't filter them out, or we still receive them both in. So we should receive just a summary route for 10.255, 11.11, and 12 as a /22 route. We'll see if it's on router 5. Show IP route. Let's see. Yeah, he is not summarizing. Because if we look back at our syntax here, it's where X is the source area. So we're bringing routes out of area. I typed in 100, right? Yeah, area 100. And that's anything 255. 10.255. Let's see, it was router 4 learning it? Yeah, he is not learning the route. Let's see, what else has he got in here? Yeah, he should be summarizing this down to a /22, and he is not doing that. And this is done at the ABR level. So we have that, and that should be summarizing down to a /22. I don't see the /22. I don't even see it here inside of the routing table because I don't see the summary address or I don't see the null 0 route in here either. Do a show run pipe section OSPF. Alright, so I've got that. Let me be a bit more specific in my configuration here. See if that has anything to do with it. So router OSPF 5. I'm going to type in network, or I'm sorry, area 5 range, and I'm going to type in 10.255. See 255. That's going to encompass a lot. So we're going to say, and you can't really use 1.0. See if that has anything to do with it. Let's see if that makes any difference. Do show IP route. And it doesn't seem to be making any change. Because here he's receiving it he sees it as an internal area, but if router 3 sees it, we should be seeing a /22 route coming across, and we don't. And I don't know why. That should not be the case. So let me show you external summaries on router 3. So right now we have do show IP interface brief. We have 4 loopbacks here configured, and what I'm going to do with these loopbacks that we had before, I'm going to go ahead and I'm going to do I've already got them redistributed in. So if you look at router 3, and if you look at router 3, we take a look at router 3. Show IP route. We have the external routes here for these guys. Technically, there's a third in there that I didn't redistribute in, but that's okay. So in router 1, what I'm going to do is I'm going to type in summary address, and then the 10 or 100.100.100.0, and what the summary mask is going to be a /24, because these are advertised, I believe, as do show run interface loopback 1000. Oh, they already are advertised as slash. So what I need to do is advertise as slash. Let's advertise as slash 21 and hit enter. So now if I go to router 2 and do a do show IP route, I should see them advertised, and see this one's working right there, but the ones for the inter area are not. So you see the slash 21 route there. If we go back to router 1, we type in do show IP route, we should see a null route in here for these guys, and you do right there. So there should be a longer route on here. And remember what I was talking about, the null route coming into play, is you should have a longer match on this box. Notice how it's only on this box that the null route shows up on. And that's because you don't want to route to this guy. If you don't have a longer match, you don't want to route to it. You're going to drop the traffic. So we have a 100. Oh, that's okay though. That's coming from 100 0. So, but also notice here we're not learning these routes in these guys. So let me go to router 3. There's a question. Where's area 100? Oh, I'm sorry. I don't even have it drawn out here. Let me draw this out real quick. That'll help you guys understand where I'm coming from. Area 100 is pretty much this area right here. And I don't have, you know what, I'll just encompass the entire thing. This is area 100. This is just a touch. This is area 100, and I'll mark that for you. So area 100. So we have that. So area 100 is all these routers. And actually, no, let me do this. I think a circle would do me much better justice. There we go. Now I can bring this out just a touch. And bring this up. Bring this over. As I'm sitting here watching, you guys are watching. Okay, dude. So anyway, there we go. I'm gonna add in a area 100. Okay, so there we go. I'm gonna go ahead and save that. Cool. So unfortunately, I don't see the routes showing up the way that they should be. I don't know why. Let me do a quick clear process on 5, and let's see here. Actually, let me go to 3 and do a show IP OSPF database or summary, and see what I'm learning here. Yeah, notice here, if we look at this, we know it's not working LSA-wise. And the reason why I know it's not working LSA-wise is, then this is why I say the OSPF database is so vitally important. Because this is actually going to help you understand what's going on. If you look right here, this is the route that we're trying to summarize, 11 and 12, right? That's what we try to summarize. And notice how it's coming in as a /32. Well, it's coming in as a /32 because it's a loopback address. That's what that address is for 11 and 12. I want to summarize that down, but it's not going to work because I'm learning it from 5, and it's because this is the advertising router. This is the summary I'm reaching. So if I do a show IP route, it's coming in as 11, so I should be able to trace route to 10.255.11.11, source it from my loopback 0. And you know what? He might not see 6 or 11. Oh, that's right. He doesn't see 3. Didn't advertise this loopback. Router OSPF 3, network of 10.255.3.3. Now let's go back over to router 11. It does take a minute for the LSA to be generated. So now we're going to go back over to 3 and drop out and do another trace route, and we'll get there all day long. That's what we want to see. We want to see connections to that guy. So now what we're going to do is we're going to say on 3 show IP route, but we still don't see that that breakdown. We don't see the connections coming in the way that they should be. So what I'm going to do here is I'm going to do a clear IP OSPF process. This is going to be basically telling everything to resynchronize. So a clear IP OSPF proc, yes, and hopefully that will take care of our problem. That's going to bounce it, and if we go to 3, we're going to do a show IP OSPF database for summary, and let's see if I summarize that down. It looks like it might have. Show IP route. No. There they are. And they're still being advertised as /32. And I don't know why. That should not be doing that. Now, because the fact that router 3 sees it, or router 5 sees it as a type 1 LSA in area 100, but as a, we go back to router 5, and let me scroll down here to give us a little more real estate to look at on the command line. If we were to do a show IP route or OSPF database for the summary, and let's look through this on area 0. And area 0 sees it as a type 1 LSA because he's the one that originates it. We come down here, we go here, he sees it as an internal LSA because he's originating it. So now we go down to area. This is area 5. Area 5. Oh, sorry. How many areas? Show, run, pipe, section, OSPF. How many areas do I have? I should have 0, 100, and 5. 0, 100, and 23, 45. Oh, you know what? Let me take a look at this real quick on 11 and 12. I think I might have show IP or show run pipe section OSPF. Okay, I advertised it in as such, which is fine. So it's there. Let me go to the router 3. Let me try this on router 3. Because I want to summarize, no wait, I can't, because it's going to be summarizing type 1 to type 3. So it doesn't make a difference. So for whatever reason, but just for kicks and giggles, so router OSPF 3, have area 0 range 10.255.0.0 and a /22 network. So I'm going to go over to, let me see if router 2 sees it as that. Let's see here. Because I should see a 0 route coming in, and or 255, 10.255.0.0. And if I was to highlight this, so I did this, and I was to type in summary and grab this guy right here, it's going to tell me exactly what I need to know about him. He's coming in /32, and now let me do this. I'm back on 5. I'm going to tweak this a little bit. I'm going to pull the range command out, but I'm going to type in the area it's going into. See if that works. So router OSPF 5, no, and pull this guy out. And no to this guy. I'm going to type in area 0 range 10.255.0.0. I'm going to go to router 3 and do show IP route. And it doesn't make a difference. Oh, there it is. Now it's showing up. But see, I originated it. Same thing here. So do show IP route. Now it's showing up. Okay, so I'm gonna say I must have the config wrong. Let me go to router 3 and type in, hit the up arrow a couple times and pull that out and type in no. So I should be learning a /22 in here, but I'm not. That's really, really weird. Router 5's got it, though. Router 5's got the summary in here, and he's originating it. So he's got the /22 coming out. He's got the longer match route. And if we look here, we have the /21 from the router 4, right? Now it's actually, let's change this around a little bit. Let me do this. Let's go to router 4, and I'm going to go to global config, and I'm going to type in do show run pipe section OSPF. I'm going to pull that command out, and the reason why I'm going to pull that command out is I want to show you guys, or I'm sorry, no. That's I typed it on router this way. So if I was to go, so okay, let me take it back down to 11 here and do a show IP route. Okay, so let me get. Now I'm learning this via 5, right? So let me do a trace route to 100.100.100.100. Okay, I go to 45.4, right? Now if I go to 101, I go the same way. Now that's because of the fact that the path that I'm supposed to be taking. You can do filtering, like through prefix lists and things like that on these routers, and distribute lists and other capabilities that would allow you to filter the traffic to choose a different path as you're going through. I'm not going to show you that in this video, but I'm just happy that the default route shows up. So I'm going to go to router 5, type in show IP OSPF database for the summary, and I should have a, let's see here. There's a question, why do you have 2 link IDs from 2 different places? Because of the fact that I'm learning the routing from 2 different routers. I'm learning this routing from router 2 and this route from router 4. So let's go to router 2 and do a show IP route. See, I am not learning the /22 in. I'm learning the routes from router 3, and the reason for that is because of the fact that he's the closest ABR to me. Actually, that's not true, because router 4 is an ABR as well. Router 4, and he'd be equal cost hops away. So if I was to go from 11 and do a show IP route, I should have multiple paths to 11. So trace route to 10.255.2.2. I should load balance. I go right to 3 to 2. Does 4 even see it? Do show IP route. I do. Oh, see, that's an inter-area route. That's why. Because I'm learning it via 45. I should be learning it via. Oh, hold on a second. That actually makes me wonder. Show IP OSPF neighbor. Oh wait, no, I'm peered. I'm peered via this connection right here. I'm in the same area as him already. Router 2 is coming in this way. Fast 1/2 or fast 2/0. Oh, that's our problem. Show run pipe section OSPF. I just noticed something. Over there. Oh, it's in the right area. Why is it not? Show IP OSPF interface brief. Oh, it's down. Why is it down? Show IP interface brief. Haha! Found it. Interface fast 2/0. No shut. That should get our connection up that way. We should form an OSPF adjacency now. We do. And now if we go back to 11 and we do that trace route, it should load balance. You know what? My SPF might be still running. I do apologize about not being able to get the area range thing to work. I mean, it's showing up in the database, or I'm sorry, in the routing table. It shows up here. I'm not sure why it's not showing up on, let's say, on router 1. Do show IP route. Router 1 doesn't see it. Router 4, router 2 don't see it. I'm not exactly sure why. It should see it. But needless to say, I don't know why, but I'm not going to sit here and keep you guys while I'm trying to figure out why it's going. The configuration is correct. But as far as I'm concerned, everything else is functioning. We have that. We have the routes advertised as such. So if we go to 11, we have the external. We know the external routes are advertising correctly, and going from there. I did some Googling to try to figure out if there's a bug issue with this particular line of code that I'm running, and for whatever reason, it shows up on router 5. The internal summarization. It shows up on router 5 right here. We know that that's working correctly, but for whatever reason, aggregation of this down to an advertisement of that to 3, 4, and 2 are just not working, and I'm not sure why. So I'm going to go ahead and clean up this video, and we're going to go ahead and I'm going to publish it. Just be aware that the configuration is correct, and I've double checked the syntax and made sure that everything is good to go, and so we're going to go from there. But just be aware that that's how you would take routes from one area to another and shrink them down to one size. A lot of times it's just easier just to use a stub area and away you go. This time it's just not working out for me. So that's pretty much all I'm going to go through in this video. I hope this has been informative for you. I'd like to thank you for viewing.